And we're back. I apologize for the delay. Something went wrong on my computer, and the program paused. But what I wanted to do now, as the Stellarium program is opening, is show you what the Eclipse is going to look like from your perspective. Right now, this program is actually free, so if you want to start using it in your own cloud for Anderson, Indiana, and we're going to now set the date and the time to be the 21st of August. And if we look up, all right, if we look up in the sky, you can kind of see the program simulating moon there. And I'm going to go ahead and click, and it's going to default to go on the sun, and I'm going to zoom in. All right, so we can actually see what's happening here. Now, by this time, the time is the current time, Eastern time. And so the eclipse would have already started here on the 20th. Let me back up the time by 1 hour, and we'll zoom out here, and we'll find the sun and the moon, and then we'll zoom back in, and we'll see what's happening here. So we can kind of see the outline of the moon right here, and of course here's the sun. So if I speed up time a little bit, you can see that they're moving across the sky there. And I'm going to speed it up to right where the sun and the moon start to touch, and we'll talk about what's happening here at that point in time. And it happens right about now. All right. So as you can see, the sun and the moon have just started to touch, and it's going to happen. They actually haven't quite exactly touched just yet, but the first touch is going to happen for you and Anderson right about 1 o'clock. All right, as you can see, I don't know if you can see the clock now, but the clock says 12:57. Right, and if we let it play forward just a little bit, you can start to see the moon. There we go. There it starts to touch the sun, and if we speed up time a little bit more, now you can clearly see that the moon has taken a little chunk out of the sun, right? And this is going to be a fairly slow process. As I said, it's going to start at about 1 o'clock, and it's going to take a couple hours for the moon to totally traverse the surface of the sun, right? Now, it is actually a pretty happy coincidence that the moon and the sun look the same size in the sky, and they are almost exactly the same size in the sky, but they're not exactly the same size. The sun is actually 400 times larger than the moon, but the moon is 400 times closer. And so because one is 400 times larger, but the other is 400 times closer, they actually look to be about the same size as the sun. So I'm going to forward this a little bit. We're going to jot down to where totality, well, not totality, but when the eclipse is at a maximum for you all, and you can see that the moon is slowly creeping across the surface of the sun there. And for you guys at this point, it's going to be darker. Okay, it's not going to get totally dark, but it is going to get darker. And you may even feel a pretty dramatic shift in temperature. Okay, for those of us who are going to be in totality, we're going to experience probably a 15-degree drop in temperature, right? And yes, I am going to be in totality. I'm actually giving a presentation over ancient eclipses in Hopkinsville, which is going to be one of the most busy cities in America that day, as far as the eclipse is concerned. And you guys will see the totality, well, not totality, but the maximum coverage of the sun is going to occur right around now, okay? Right around 2:30 or so is when you're going to experience the maximum that you'll see from Anderson, Indiana. It'll actually be right around 2:20, Okay, so for you guys who are going to be in school with students, 2:20 is the time to actually look. Uh, Now, I understand that that's probably toward the end of the school day, but I don't know what kind of arrangements you guys are making with your students, if you're holding them longer or what. But that is going to be the best time to go outside and try and see the maximum coverage. Now, you'll see this star out here. This is the star Regalis, and it's in the constellation Leo. And you may be able to see it or not. I can't guarantee that it'll get dark enough for you to actually see stars. For those of us in totality, it will get dark enough, right? But there's always the hope that you might be able to see some stars and planets. If we zoom out, okay, you'll see that Mars is out here. You probably won't see Mars. Uh, you probably have a better shot of seeing Venus out here, all right, if you can, if it's visible. But that is what the eclipse is going to look like for you guys in Anderson. It's going to be right at about 90% coverage. But it'll still be bright enough. You do not want your students to look directly with their eyes at the eclipse. Okay, you don't want them to view the eclipse directly. And one of the things I thought I would do, since this is actually the topic that I'm going to be giving my talk on in Hopkinsville, is give a little bit of some of the mythology behind eclipses in ancient cultures. Now, I'm not going to go through my entire presentation. That would take a lot longer than the 15 minutes we have in this video, but I did want to highlight some of the um, mythologies, if you will, that ancient peoples had regarding eclipses. And so one of the first cultures to really start to look at eclipses and document them in a quote-unquote scientific fashion were the ancient Chinese, and they were stellar astronomers, not to make a bad pun, but they were phenomenal astronomers. They kept very articulate records of everything they saw in the sky for thousands of years, and they're some of the best records for ancient cultures that we have. Now, eclipses are far more difficult to predict than things like when planets are going to appear. And so, because these events were so chaotic, they were not able to be predicted very precisely in the ancient world. A lot of people attached very significant religious or cultural significance to these. And so the ancient Chinese actually thought that an eclipse was a dragon, a solar eclipse was a dragon that was trying to devour the sun. And so what people would often do is they would gather together as a community, and they would beat pots and pans or something of that nature to try and scare the dragon away and save the sun. And some people still follow that tradition today. In fact, in the early 1900s, the Chinese Navy fired some cannons, symbolically, of course, to try and scare the dragon away as it was eating the sun. One famous story that comes out of China is these two astronomers, Ho and He, and the legend has it, this is not necessarily 100% true, I can't prove that it's true, but legend has it that they were executed for not being able to predict an eclipse, and the emperor beheaded them. The ancient Chinese thought that eclipses meant bad things for an emperor. So if you were not able to predict it and the emperor wasn't able to prepare himself accordingly, that was a very bad thing. So these two astronomers, Ho and He, were beheaded, according to legend, for not being able to predict the eclipse. Now, the eclipse that they did not predict, right, happened in 2037 BCE, which means before Common Era, or BC, if you will. And so we're talking about thousands of years ago, and today we would, of course, forgive ancient astronomers for not being able to predict eclipses with how complex the orbits of the Earth and the Moon are relative to the Sun. But the ancient Chinese did not have the same graces that we do today. And so, because these astronomers were not able to predict the eclipse, legend has it that they were beheaded. Um, Now, China started to actually keep systematic records of eclipses around 720 BC, and they were also one of the first cultures to recognize that moonlight seemed to be reflected sunlight, and that was a pretty significant breakthrough. By about the 4th century BC, they were actually able to start making some pretty systematic predictions of when eclipses should occur. Now, this was a very difficult process for various reasons, but they made it very solid attempts and were some of the first to really make the attempt to predict when these types of events would occur. And they were one of the first people to notice. You'll see here this 130-month recurrence period. That is not an absolute recurrence period, but it seems to be that solar eclipses follow a 135-month pattern. And there are reasons for that. I'm not going to go into the details, but sometimes eclipses occur within that pattern, sometimes they don't, but more often than not they will, right? But it also, as we've seen in the videos before, they don't necessarily hit everywhere on the Earth. So even if you predict that an eclipse should occur, you may not see it if you're an ancient Chinese astronomer. The ancient Vikings actually believed that eclipses were sky wolves that chased the Earth and the moon, or the sun and the moon, rather. And these sky wolves are named Skoll and Hati, and they continually chase the sun and the moon. And their legend has it that during Ragnarok, which is going to be the end of the world, they're incessantly going to chase the sun and the moon. So we will see lots of lunar and solar eclipses during that time. But they don't exactly say when that time is going to occur. Now, in ancient Babylon, the ancient Babylonian astronomers were the first to discover what we call the Saros cycle, which is related to that 135-month period, but it's not exactly the same thing. It's an 18-year or 11-month, 18-year and 11-month period during which lunar eclipses repeat themselves. So if a lunar eclipse repeats itself, then that means that the sun and the moon can be favorably aligned, and within the window of a lunar eclipse, a solar eclipse is possible, right? But solar eclipses were also very important for Babylonian kings. Legend has it that a scribe once told the king, if the sun is at its rising, like a crescent, and wears a crown like the moon, the king will capture the enemies of his land. And so this was very important. If we could predict when this would happen, then the king would have good fortune. So that was very, very important. One unique instance was when an eclipse actually stopped a battle between some ancient Greek warring tribes, the Lydians and the Medes, and they were fighting in 585 BC. And according to one of the most famous Grecian historians, an eclipse occurred, and because this eclipse was actually predicted by one of the ancient Greek philosophers, everybody took note of it, and when the eclipse actually occurred, everybody laid down their arms and they ceased fighting, and they were anxious to agree on peace. Now, one of the most interesting to me things to come out of ancient cultures with eclipses were the Mayans. And not so much for what they had to say about the sun and the moon during an eclipse. They did recognize that it was the moon passing in front of the sun. And in their culture, they believed that a snake, so not like the Chinese with a dragon, but a snake was eating the sun. But one of the things that they actually did was they built a very complex mathematical analysis of celestial motions and were actually able to be the first culture to precisely predict when eclipses would occur. And there is evidence that they actually predicted back in 1100 AD that they predicted a 1991 solar eclipse, and it happened within a day of their prediction. So that's pretty incredible. So that is some basic information about eclipses. I hope you've enjoyed the two videos, and if you have any questions, feel free to contact me. Thank you. Bye.